Hi everyone, welcome to my channel. Today, let's discuss about machine learning concepts. So this is a short video, not into too much detail, but basics of machine learning. Uh, in the last video, we have discussed the overall artificial intelligence and what are the subsets of it. Like you have machine learning, and then deep learning, and then generative AI. Uh, Today, we'll discuss about the machine learning part of it. Machine learning, as you know, it just enables, it just sorts a group of algorithms, and they enable computers to learn from data and make decisions or predictions. Um, yeah, so that's basically what machine learning does. And it can be classified broadly into three types based on the nature of the learning system and the data available, whether you use labeled data or unlabeled data, or where the data is coming from, etc. So, first thing is a supervised learning, which is the most common. And in this, the so consider these are all models. So there can be multiple models for each one of these. So supervised learning, it works on the model works on a trained data set, trained label data set. So what that means is you have clear labeled data. So I have this house prices. So the list of house prices or any number of parameters. For example, size of the house, location, etc. So the data is labeled. And then you have supervised learning, which works which is a model again, and it works on a unlabeled data set. You just give the data to, like say, you just give the data of a class. So, and then it just makes clusters out of it, segregates the data, identifies the patterns. So there's no labeled data as such for supervised learn. Unsupervised. That's when you use unlabeled data. It is called unsupervised learning. And then you have reinforcement learning, which is basically you can make it from this word reinforcement. So the learning is reinforced. So it's where you have an agent. Basically, agent. So agent means it's just a, you can call it um, a tool, a model. It learns to make decisions by interacting with its environment. Say you have a robot and it learns, basically, it moves around. If it gets in, hits an obstruction, it moves away, or if it's a clear path, it moves forward. So it is rewarded. The Say in this case, the robot is rewarded or penalized. So if he does a good action, right action, it is rewarded. If it does a wrong action, it is penalized. That's how it learns. It's just like training a kid. So in this one, we just touch upon the supervised learning part. And within supervised learning, you have two main areas, two types, which are regression and then classification. So the regression is, you might have heard of this number of times, linear regression. So you have a set of data, set of input data, and you have output data, and you want to make a prediction of what happens. So what is the weather like? What will be the weather like tomorrow? Because it had been a sunny days for the past 1 week, and before that, and even the past year, same time in July, it was sunny. So what is it going to be weather tomorrow? So you make prediction out of it. So you have the data, the whole weather data for the past 1 year, and you can make prediction what is going to happen tomorrow. Yeah, that's just a simple example, but it's far more complex when you want to predict the weather. Similarly, here the example I have taken is the house prices. So you have square feet of the house, how big is the house is, and what is the price of the house in terms of thousands. So bigger the square feet, higher the price. Then you would want to plot this in a graph and then get the draw a line that is closest, like that matches that is close fit to these all these points. We'll get to the maths in the next video, how this thing works, what is the maths behind it. And then if I want to predict for 2500, so I will go to the 2500 on the x-axis, 2500 square feet. Again, I missed an important one because they in the linear regression, you usually there are two kinds of variables. One is dependent variable, and another is independent variable. So here, uh, price of the house is dependent on the square foot. So price is a dependent variable, and square feet of the house is an independent variable. If you add location, that's another independent variable. So price will then depend on location as well as square feet. Then that will become a three-dimensional. So now you have x, y, and then you become a z dimension. So you can have number of dimensions. Yeah. So that's where you need vectors to deal with the machine learning or further using those models. So the concept is regression within supervised learning. It needs labeled input data and the output is continuous, which means if you take, for example, 2501 square feet, 2510 square feet, the output is continuous. That means it keeps giving it output. So it can be very very minimal change or massive change. It gives you output for a given square feet. Here it gives you the output. And these ones you might have seen in your high school maths or further as well. So you have something called simple linear regression. That means you have only one um, independent variable, one dependent variable. You have multilinear regression where you have um, multiple independent variables and one dependent variable. And examples for these are usually stock price prediction, stock market, uh, house price prediction, weather forecasting. Anything you want to predict based on the labeled input data, that is called regression. And then the second branch of the supervised learning models is classification. So what is classification? So you have the data. Again, this is also labeled data because remember, supervised learning data works only on the label data. So you have label data, but instead of output being continuous, in classification model, the output is categorical, like yes or no, 0 or 1, whether the event will happen or not. So when I say when the event will happen or not, so that will draw you to probability. Probability of that is happening, odds of an event happening, etc. Right? So classification. Remember, for now, we'll get into this to math. We'll get into maths of this later. But just remember for now, the probability of a thing happening classifies whether the classification will use probability, odds, log odds, etc. So to derive or to predict an event happening or not. Say, for example, here you have a body mass index, and it is somewhat related to diabetes, right? So this again, I'm taking only one independent variable and one dependent variable. So it is somewhat related. So let's take a so in a classification problem, you will give body mass 20, there's no diabetes risk, and from 23 there is diabetes risk. So if I tell that is a person with body mass index of 26, then you will say, yeah, they are probably at risk. If you plot this, so instead of a curve, instead of a line, which is linear regression, what you see here is S type of curve, which is like your probabilistic um, decision whether if the event is happening or not. So this classification examples can be spam detection. So you get an email and you get an email and then Outlook or Gmail, it just classifies whether the email is spam or not. How is it doing that? So based on some, so it has some set of inputs, keywords. Um, yeah, say it says you have learned a large amount of money and it comes from a dodgy email address, and this depends on the formatting sometimes, etc. So it just identifies based on these, and it applies logistic regression and says, okay, yeah, this is a spam, and or this is a good mail. And then text classification reviews. So you might have seen the reviews on Google or TripAdvisor, etc. So it just identifies the mood of the review based on the keywords. So, or it just classifies, say, it is good, bad, medium, and it can give a rating as well. So this is classification. So yeah, thanks for watching. Please like, comment, share, and subscribe. So we'll get into the details of linear regression mathematics next in the next video. Thank you.